Welcome everyone officially to the second MLOps London meetup of the year. We usually hold these meetings in person at Rise London, which is a incubator created by Barclays. That is where Sheldon, my employer, has its offices at, and this is in Shoreditch in London. But unfortunately, the venue that we always use is currently being renovated. So they told us that we were not going to be able to use it until May, and we decided to hold the MLOps London March edition as a virtual event. So without further ado, I just want to welcome everyone. And before we begin, allow me to share a little bit about myself, about my employer, Sheldon, and why we do what we do with MLOps London, why we host the MLOps London. So again, my name is Ramon. I work as a developer advocate at Sheldon. That means that I do a lot of things in terms of education, creating applications with our products, showcasing to people all the cool things that we can do in machine learning with our products. So what do we do at Sheldon? We are a machine learning operations platform, but we focus on the last end of the machine learning life cycle. So once you have collected all your data, trained your model, evaluated it, you can come to us and say, I want to deploy it. So we help you deploy your model, we help you explain the predictions that your models make, and we help you monitor the decision, the predictions that your model makes, the data coming in, the data coming out, and the predictions coming out. We do that in different ways. We have different products. We have several libraries in Python for doing evaluation, drift detection, and machine learning serving. And then we also have a tool that is hosted on top of Kubernetes that you can use to create inference graphs. So if you can think about that as I take an input. So for example, right now I'm speaking, and if my words were being one model, if they were then being summarized into what I said in this entire conversation, that will be another model. And then if they were being translated into another language, that will be another model. And that will be an inference graph. And that's one of the things in which we specialize. So with that out of the way, the one last thing that I want to mention. So we host the MLOps London meetup. And we do this because we love to contribute to the community and give a platform to people that have cool things to share. And with that in mind, today we have three amazing speakers. Our first two speakers come to us from SurrealDB. SurrealDB is a database of a one-of-a-kind database, but it's also an entire ecosystem of different tools. And today with us, we have two key figures from SurrealDB. One of them is Tobie Morgan Hitchcock. He is the creator and co-founder of SurrealDB. Before founding SurrealDB, he developed and consulted on numerous cloud-based architectures and platforms with a focus on distributed databases and highly available architectures. He gained as a software engineer, and Master's of Science with distinction from the University of Oxford, where his thesis was focused on highly performant version key value data stores for use within graph databases, an idea which formed the basis of SurrealDB and SurrealKV. And then joining Tobie, we have one of the lead software engineers at SurrealDB. His name is Maxwell Flitton. And he also has his right hand, which is the main speaker, his son, which I saw a second ago in his video. So anyways, without further ado, I'm going to pass it to Tobie and Maxwell to take it away. Feel free, everyone, to post questions in the chat, and then I'll collect them all, and then we'll get through them at the end of Tobie's, or however Tobie and Maxwell would like to go about taking questions. So without further ado, I'm going to pass it to Tobie. Tobie, take it away, please.
Awesome, thank you. What a great introduction. Let me just bring up my screen. So yeah, so if you hear Maxwell's joined with his son at the moment, who's currently looking after. So if you've got any, if you hear any sounds of a different tone to either me or Maxwell, then that'll be him. But hopefully we'll get through this. So yeah, so I'm the founder of SurrealDB, and Maxwell joined us. He is a Rust book author. He's written the books on async operations inside Rust, and also the integrations of Rust and Python. I think, correct me if I'm wrong, Maxwell, but I think you're on your 4th book now, which you're authoring. So what Maxwell doesn't know about Rust is not worth knowing, I guess. So what is SurrealDB, and what does it have to do with ML and MLOps? As Ramon clearly expressed really well just a minute ago, SurrealDB is a multimodal database that handles lots of different types of data and querying and index types. It really is, to different developers, a very different thing depending on what your interests are and what your specialities are as well. So at its core, first of all, I'll come back to that second question during the course of this talk, because what we've been working on over the last 6 to 12 months is something called Surreal ML, and that's what really plays a part in SurrealDB. So SurrealDB is a traditional database. It's a document data model underneath the hood, with support for arbitrary depth objects, arrays, durations, date times, strings, numbers, and decimal values as well. In addition to that, it's a graph database, so it has the ability to support single direction graph record pointers and bidirectional graph traversal. So this is all really important when it comes to being able to run inference and model execution over your data. The third model that we support is time series data, so being able to group your data by specific categories or time, so that you can query that data without any indexes, and really efficiently as well. And then fourthly, we have an SQL-like query language, so it's very similar to traditional SQL. It has select statements, insert statements, and everything else that you'd expect, but it goes a step further in that it has support for nested object and arrays and graph traversals as well. In addition to that, and this plays an important part in the functionality that you get in the MLOps function in SurrealDB, is that it is a backend web database. So you can connect directly to SurrealDB right from your end user device or a browser. And because of the advanced permission syntax that you can define on every row, or every table, or even every field of every row, and bearing in mind that a field can be an embedded field or an array value, for instance, you have complete control over what someone may be able to see in terms of data, and then also what someone may be able to run in terms of a user-defined function or an embedded function or a model. And that really brings us on to how it can be run. So SurrealDB is designed, it's fully built in Rust, and for that reason it's designed to be run as an embedded database, so something that runs in Rust or in Python as a traditional database server, so a single node database server with persistent storage, or as a distributed, highly available, highly scalable terabytes, potentially even petabytes of data distributed cluster. Because of that, there's no difference to how SurrealDB is run in any of those environments. There's a difference in terms of how it's set up and configured, but in terms of how you run queries against it, statements and data, really you're just limited by the environment in which it's run. If you're running on a single node, you're limited by the ability to scale up. If you're running in an embedded node, you're limited by memory constraints or device constraints. But really the way that you query and work with a database is exactly the same across the different ways of running it. And I think finally, the ways you can run it in embedded mode are in native libraries or SDKs. So we've got a WebAssembly plugin where you can actually run SurrealDB inside the browser, storing and persisting its data to IndexedDB. The same thing in Rust. So in Rust, we support RocksDB, SpeedDB, and now our new key value storage engine called SurrealKV. And the same thing for Python, Node.js, and Dino as well. So in Python, you can now connect directly to SurrealDB running inside Python, and you have exactly the same functionality from querying, from storage, from updating data and permissions that you'd have in Python as you would do on a server. That brings us on to ML, which is the functionality that we're looking at and talking about today. So Surreal ML is all about, it doesn't really touch on training or altering the pipelines that developers use to work with the model before they infer against it. But where Surreal ML is designed to completely change the game is on the inference and the scalability of that inference when it comes to running models against your data. So Surreal ML is a runtime which is embedded right within SurrealDB, whether that's running as an embedded node, single node, or multiple nodes in a cluster. And through some things that we'll be looking at today, some of the functionality of Surreal ML, it gives developers and platform engineers the ability to work in a more performant, more consistent, and a more reproducible manner with the models and with those models as they run them against their data. So today we're just looking at Surreal ML and how it works within the database. That was a general overview of what SurrealDB is and why some of those features, we'll come back to it a little bit later on, benefit Surreal ML as a function. So Surreal ML is it's an open source package. You can find it at github.com/surrealdb/surrealml. And currently it is a binding between Rust and Python where you can build your own models. And I'll be talking, well, I'll be handing that over to Maxwell a little bit later on to talk about exactly how it works and how, what the magic does. But effectively, within Python, within your current pipelines, whether that's your development processes, your development workflows, or even running when you move to continuous integration environments and pipelines in the cloud, you don't have to change how you build your models. The only difference is Surreal ML enables you to more easily scale and work with models in production. We support any model that builds into Onyx, whether that's an Onyx model itself or whether it's from PyTorch or TensorFlow. Currently within Surreal ML itself, we handle PyTorch models natively, so they automatically get built and compressed into Onyx and then packaged into something we called Surreal ML file. So this Surreal ML file has understanding of the type of data in the file, the model, the normalization data that the model accepts, whether that's raw data or whether it's formatted according to the data from the database. And then it contains the actual raw model itself. Now, the beauty of how this can be run in SurrealDB is down to versioning. So versioning, very similar to how it works in Docker, effectively gives you the ability to version your models and have consistency as you update those models over time. The real benefit, though, is not really about building different versions and increasing that version identifier over time, but it's really about how you then call those model functions against the data in your database. So in a few slides, or the next slide, I'll be looking at how Surreal ML is actually executed inside SurrealDB. So when you upload a file, effectively we take the raw binary data. The Surreal ML file itself is packaged as raw binary data. It goes up into SurrealDB, and SurrealDB can store it in many different places as you choose. So if you're running it yourself, you're running SurrealDB yourself, and you want to store it locally, then you can specify storage locally. But alternatively, we can also store it in S3, and we can store it in Google Cloud Storage and Azure Cloud Storage as well. And what happens is we understand that the model identifier is stored in our key value store, so it's very quick. and then the model will be cached on the nodes that run it. So if you're running in the cloud, you've got 20 nodes, for instance, and you're calling inference functions on different nodes, that model will have to be downloaded onto that node and cached. And that all happens behind the scenes seamlessly without you having to think. You just specify where you want to store that model in order to run it at a later stage. Now, when it comes to actually running the model, effectively, the SurrealML model itself becomes a function. So here we've uploaded, in that previous slide, we uploaded the model and we called it ML insurance prediction. So we've namespaced that model into an insurance group. And then we're using that function. So ML insurance prediction now becomes a function, and it automatically understands from the SurrealML file, and therefore from Python and the Python build, the exact version that model is. So we can now add other versions to this database. We can increase those over time, and we can still have access, if we want to those different previous versions. Now, the interesting thing is we can also give people access based on permissions to potentially only the latest version. Or we could say, this new model is still being tested. We're still putting it through its paces, and we don't want to give people permission yet until we know that it works in an efficient and correct way. So with the permission model of the database, effectively, you are then able to say who can't do anything with that particular model. The next step is really bringing machine learning into the traditional queries of any database, really. So now, instead of having to have and connect up APIs and different services and containers potentially in a cluster and push those tasks off to different containers and then receive the responses back, all of this happens invisibly to the user, and it happens inside the database itself, right alongside your data. So here we're saying, look, I want the name field, I want the age field, and I want to predict a value. Let's say we're predicting whether this person is likely to buy. We've got a mismatch on the name of the model and the field there, but go with me on this one. So is person Tobie likely to buy this property based on their name, their age, their disposable income, and their purchase before? So whether they've purchased a property before. And here you can see we're using a number of different things. So we're using the age field. We're using the income field, which has been rounded up or down. And then we're using the graph connections to follow other purchased properties in the past. And we're saying, have there been purchased properties in the past? And we'll push that in as an argument. The model understands which arguments it expects to receive based on the definition in Python. So in SurrealML, and Maxwell will be talking about this in a bit, you can define right in Python what fields you expect, and those fields get converted behind the scenes to the data that the model expects. Now, this is powerful in its own way, but the real power comes when you can turn this select query into an asynchronous triggered event effectively. And that's exactly what's happening here. So instead of saying, I want to select all 1,000 users from my database, and on every user, I'm going to run this machine learning model that takes 2 seconds, it's going to be a very slow query. But what you could do is you could say, look, whenever a certain field changes on any user in this table, I want to run this machine learning model asynchronously and update that record with the value that model has returned. And that's therefore you've then got asynchronous machine learning model execution running at scale, so you can spin up as many SurrealDB compute nodes as you want, and able to be run in the cloud with storage from S3. You don't have to think as a developer about caching, about scaling up the compute, or anything else like that. It's just completely invisible to the developer. Going on from this, you can then use a traditional query. So this probably makes sense to a lot of users, in that I want to select all users where that likely to buy value is true, and only where they've been updated in the last day. This is just pulling out those users who are likely to buy and therefore I'm more likely to sell to. But now that we've got those asynchronous events, and with another piece of functionality in SurrealDB, you can change that query ever so slightly so that we now get a continuously live stream of records as they're updated by those models in that queue. So when user records are being updated, the machine learning pipe models and inference tasks are being pushed onto an asynchronous queue. That asynchronous queue is then updating records, and our application receives that update as and when the likely to buy field evaluates the true. So all of this can be done without having to think about containers or APIs or services or anything else like that. It's completely invisible to the developer. Now, here, the magic of how this works and the way we built it is really down to Maxwell. So I'll let Maxwell take over and talk a little bit about the philosophy around Surreal ML, who's using it, and really about how it works in Python and how it's implemented.
Hello, can everyone hear me? Is that good? Fantastic. Okay, cool. Sorry, Tobie's just gonna obviously still remove the slides, so there'll be a bit of a direction because he had the latest update. So hopefully most of you don't use Pickle, but I've looked under the hood of a lot of machine learning systems, and they do use Pickle scaringly. And considering this is a machine learning meetup, I'm sure that many of you are aware of what usually goes on. You train your Python script, you use your Python script to train your model, and then you store the weights, and then usually people pickle them, I've seen. We sometimes use Onyx, we use tracing for the PyTorch, but sklearn, which is a very nice, easy to use module, because of the way it's kind of defined, people kind of just generally lean into pickling it. Now, there are some tools that convert as Onyx, and we've utilized them in our system, but we'll have to just really go over like why we kind of moved away from, obviously pickling. So if we go on to the next slide, we can say that anyone who's not fully aware, and we'll move on to more interesting stuff in a few secs, is that pickling is obviously very bad. So pickling is very secure. It's just raw Python bytes. So I can build a class that fires a function as soon as it's loaded. Your code will still break because you've loaded the wrong pickle, the wrong object, but it'll fire my code before you throw an error. It's also very brittle, so you can have different versions. You even have it where if you don't do deep clones and you're not very careful with it, even if the Python package that you're referring to changes, then it can cause breaks. And I've seen this with like machine learning systems where they're using Celery and they're using all these really fancy pipelines and they're pickling it at the end, and they have to build their own libraries and isolate them. And there's even people who wrap entire pickle their models in their own individual Docker images, which are obviously not very scalable in that sense. And also it's very highly coupled. So we wanted to move straight away from that. We wanted something that's really language agnostic, and we wanted something that's kind of system agnostic as well. So if we go on to the next slide, we can see what the anatomy of a Surreal ML file is. Now, we kind of picked Onyx because Onyx, is supported by Microsoft. There's a lot of tools that convert a lot of different things to Onyx. It's a protobuf, so it's kind of language agnostic, so it's very safe as well. And then we've got this like metadata, which is just kind of string data. So we wanted to keep this as easy to work with as possible, because what you saw with what Tobie showed you with the power of like the SQL syntax or the SurrealQL, we know that we kind of add value anyway in that field. So we don't have to kind of build a file system that kind of just locks you down and forces you to use, our system, because we know that that already adds value. So instead, we wanted to make it as easy to work with as possible. So what happens here is that we have the first 4 bytes of first 4 bytes of the file is an integer, and it tells you how many bytes you have to read to get the rest of that string, to get the rest of the header. Your header can be completely empty, and we will go over the different types of compute as well. You don't even have to have a header if you don't want to. And then we have the Onyx. So we wanted it very simple so you can work with it. You're not locked down. You feel very comfortable. We obviously talk to Onyx using the C++ library because that's what it is. And that completely binds to a Rust ML core, which a Rust program can directly talk to. But we can also use Python bindings as well. So there's also Python bindings that talk to the Rust ML core. And there's nothing really stopping us. It's just obviously time and constraints and stuff, and we have to kind of work out our roadmap. But we could also add other language bindings as well in the future, because these bindings are kind of structured in a way where they're own isolated modules. And in Rust, we have these like compilation features. So you select like something that you want to compile based on a certain feature, and it'll only compile that. So you can say, look, I'm only going to compile it with the Python bindings, or I'm only going to compile it with no bindings because I'm going to use the Rust core in my server, or I'm going to compile it with JavaScript bindings if we support JavaScript bindings, or if someone wants to contribute JavaScript bindings. And that's like what the reason why we've got the Rust ML core and we've got all these bindings, well, we've got the Python bindings so far, is that we want the same code that runs locally on your computer to also be the same code that's executing it in the server. And we want to try and reduce the kind of friction in that sense. So to get a feel for what we do, if we just go on to the next slide, we can actually see what we've actually got. So this is like if you do a pip install and you install SurrealML directly from the repo, we have like, you also see that we're using sklearn here because we also support like PyTorch. But sklearn, you can see we do a basic linear regression, and we've given you some very basic house price data, which is obviously stuff that everyone kind of has looked at when they look at an introduction. We fit the model, and then we create a SurrealML file object. And you can see we put a name, we put the inputs in because they're going to trace it and they're going to convert the sklearn model to Onyx. And then we also have an engine enum, which is sklearn. The reason why we've got this engine enum is that, again, if people get involved and they want to support other engines, we can kind of stack them in, so it kind of looks at the enum that you're passing in. It's got completely different adapters based on what you're passing in. And we also have separate and just single adapters to connect to the Rust from the Python. So we can also, again, do that with other Python bindings. We then, like we see on the right, we add some metadata. You don't have to add metadata, but you can, and it does help. So it will help with a certain computation, which we'll cover. And you can see that we add the square foot and the number of floors. We have to be careful with that one, with the order in which we put them in, because it will map the input. Then we add some normalizers if you have normalizers. And then we add some information about output with some normalizer as well. And then we save it. So you can see this saves it as a SurrealML file. So if we go into like the next page, we can see that we execute this. Now, Tobie showed you some other things, some more fancy things, but this is like if you wanted to get this running tomorrow and you didn't know anything about SurrealDB or SurrealML, once you've uploaded it, there is a function that just says upload, and you just point it to there, and it's in the documentation. You can see that then we have the version, and we can actually pass in. If you're from Python, you'd say dictionary. If you're from JavaScript, you'd say it's an object. But you can see that you are just passing in the key value, the name of the column, and then the value of it. And what this will do is what we call a buffered compute. So it will go through the header in that SurrealML file, and it will order it, map it to the right order inputs, to the right vector, and then it will apply normalizers before putting it into the raw compute if you've got normalizers there. So you can see that, like in this toy example, we create some things about square listings, and then we then do a select, and we call that thing. And then on the bottom left, this is what you'd get back. So it would obviously just return 2 of the rows instead of 3 because it make the computation. One of them is obviously not in that range, is below that range. But you can see that it's imputed it and put it in as a price prediction. So you can see how it just kind of runs next to it in that sense. So if we go on to the next slide, so we're not just kind of like cobbling together things and saying like, well, this kind of works, because like we know, especially in MLOps, this is something that you guys are definitely interested in, is we could talk about loads of really fancy stuff, but the stuff that kind of works and works really well is something that's kind of more beneficial, right? We want to get the basics right. So I'm currently also a researcher at King's College London. So for those who aren't aware, King's College London is like the 4th biggest bioengineering department in the world. It's the biggest bioengineering department outside of the USA. And it does a lot of things like surgical robotics, implants, all that sort of stuff. And it is going to be announced as the London Institute of Healthcare Engineering. And it's not just that I kind of did a bit of things for Kings, and I'm doing a bit of things for Surreal, we actually have a full-on legal partnership. We've signed documents, you know, like we're supervising PhD students, that sort of stuff. And the reason why we do it, if we go on to the next page, is that this is our robotics lab that we're kind of working with. Now, they obviously have an interest in making sure that robotics work. We're a database company, we're not a robotics company. But the reason why we're partnering with them in this sense is that we get really tight feedback. So they have like certain, you know, needs. They're running like a load of streaming data through like rigs of GPUs because they work with NVIDIA and Medtronic and that sort of thing. And we need to make sure that like our Rust kind of ML model, like engine, works, and it's like does it to a high performance. We're still in the early stages, but we started working with them in terms of like pipelines. So instead of us like putting out a new feature and then it kind of annoys the public and then you get loads and loads of issues and so it doesn't really work, we can kind of like test buffering, or we can test like batch writing or batch training, you know, and also like what happens when we get like high volume data? Do we start to batch write it to disk, and then do we have like active threads in the back end that are like feeding it in batches to the ML model or something like this? And we get that tight feedback mechanism directly in this lab, right? They're happy, we're also happy because we're not annoying members of the public with experimental things. And we get to see the direct feeds. And if we go on to the next slide, you can kind of see this is just a screenshot really of what's going on. So if we see it's Surreal ML modules pipelines, we're starting to build out pipelines, and we're starting to build out like this is RGB data because the robot is streaming in video data essentially, which is RGB frames. And we're connecting stuff from a cable, and we're using Python bindings with Rust. So what we're doing here is the academic that's kind of training the model with Python is using under the hood, apart from the actual like PyTorch or the sklearn or whatever they're using. I think in this sense just PyTorch because it's convolutional neural networks. They still use their own Python kind of like code, but the pre-processing is Python bindings with Rust and tons of unit testing. And then as a result, the exact same modular pre-processing and exact same inference engine, which is Rust under the hood, get fused together and then they run in production. So it kind of is like if it runs locally, it will run exactly the same way, you know, in production. And we've already like highlighted an error with this. And this is the thing, like, so before I did physics and became, you know, when I became a software engineer, I did a previous degree, which was I was an A&E nurse. And what we generally find is that people always think that like A&E is really, you know, lots of things going on. You have to really think on your feet. But actually, it's the really basic stuff that if you get that wrong, it has huge knock-on effects. So just forgetting to prescribe something, or forgetting to write down that allergy, or forgetting to put an allergy band on the patient, these are the things that really cause like knock-on effects. And I think this is just a way of life, because what we also found in these pipelines was that because we were unit testing each module, and we were seeing each pipeline and doing comparisons, the academics at King's, very smart guys, it's a mistake that anyone can make, just like anyone could forget to put an allergy band on a patient. They were using the wrong compression for their video feed, and and it didn't pass our tests in the pipeline. And what it turned out was that this type of compression had a bit of variance in it. So what they could potentially train on would be different from what they would get in production, because it just wasn't matching our thing, our testing. And they've sorted it out. They used a different type of compression that doesn't, you know, lose data in a kind of where there's some variance, a bit more computational power to be used, sure, but obviously it's much safer, right? The model they train for is going to be processed exactly the same way when they put it into production. And this is kind of like the ethos we're going down. It's like we want to do all the boring stuff, so it works. And so you can focus on doing like more interesting things around your domain, because we're not domain experts. I don't know as much as the King's professors in surgical robots, that they're literally professors in it. But I do know about Rust and unit testing and pipelines and async. You know, I wrote the O'Reilly book on async Rust. So that's where I focus on, and that's where we really try and push, you know, safety standards to another level. If you do look at the repo, we do also have automated CI that kind of trains these models in with the different engines, with the PyTorch and the sklearn, and then it runs them through a load of different tests, through unit tests, through end-to-end tests. Right now, it's just the sklearn linear regression and the PyTorch linear regression just to show that it's working. We are using convolutional neural networks with Kings, but we obviously can't release those models because that's stuff that they're working on. But if anyone wants to contribute or work with us, if they say, look, I have this particular type of model, I would like that in the end-to-end CI tests. I'm like, sure, yeah, we want it. So like, you want to be purely comfortable every time we do a new release, your type of, you know, engine / model gets tested and you're happy with that. And we can also see that with like the Python. This is slightly further ahead. It's just the pure the Python client for SurrealDB. It has over 290 tests, all like a whole range of different Python versions and a whole range of different SurrealDB versions, all the way down to 1.0, just to test to see if this all backwards compatible and it all works. It's not super sexy, but these are the things that break your machine, right? When you're deploying. So if anyone has interest in kind of working with us in that sense, we're more than happy to work out some sort of testing strategy and put it into the CI as well. As long as you give us a very generic, obviously, you don't need to give us the weights, just a very generic model that you would be using in that sense. And I think that's it.
Awesome. Yeah, Maxwell, thank you. If anyone's got any questions on Surreal ML or SurrealDB or anything, would love to answer them as best we can.
Thank you very much, both of you. What a fantastic talk. I mean, seriously, I think this is the first time I see a lot of these use cases, models from within a database, or the database completely served like as close to the user as possible, and a lot of cool stuff. I feel like even though you probably can cover a million use cases, I feel like the whole hype right now is on LLMs and things related to foundation models. And it's quite nice to see that all these cool and innovative ways of doing inference that still serve the most critical ML use case, like use cases of for detecting fraud detection, for example, or things such as credit scores or the day-to-day stuff that we interact with. So this was really cool to see. If anyone has any questions, please feel free to unmute yourself and ask your question directly. Or put it in the chat if you like as well.
While people are writing or thinking, I just want to come back on that. Like, look, obviously LLMs are a massively growing and interesting space right now, but I think it's we shouldn't forget that a lot of large enterprises, research institutions, big organizations can't rely on LLMs necessarily for a lot of the models they're doing. They have to have control over the weights, control over the data, control of over the how that model was trained, and therefore what you find in a lot of these cases is they're going back to the traditional models, the traditional approaches, rather than putting everything into an LLM. So for us, it's about supporting both. It's about supporting the traditional pipelines and bringing that into the database and as a function, but also supporting those newer approaches as well. And that's really key. When you're looking at financial fraud detection or insurance or bioengineering, medtech, a lot of these things are still having to build it the non-foundational LLM way.
And also, just to add to that, that's the whole point. Where it's like, I don't know if you've seen there's a lot of frameworks now, Like for example, I think Llama Index has a way to interact with tables because at the end of the day, like a lot of the data that we're going to be using for decision making on a day to day is going to be sitting on a database, and it's going to have some sort of relational component to it. So that's super key. But yeah, everyone, any questions that you got, please unmute yourself and
those are just some points, and it's all gonna be stress for you. So.
Oh my God. Wait, sorry.
I think they might have unmuted themselves accidentally, folks. If you do have a question, please unmute yourself. I have muted you in case this was an accident. All right, any questions? Anyone? Okay, well, maybe one question, Maxwell. So we saw a lot about, or you walked through, or Tobie, you as well walked through a lot of code. I guess, how easy is it to like combine all of these things together? Is it because what led you to the decision to pick Rust in the first place to go about the core programming language for your infrastructure?
I'll answer this first, but I know Maxwell's got other reasons because Maxwell's been working in Rust for a number of years. SurrealDB was initially built in Golang. Rust was a complete rewrite. We literally there was a balance between do we rewrite the query parser, do we rewrite the executor, the core engine, and actually we decided to rewrite the entire database from Golang to Rust. For us, that was one of the best decisions. I know. Casper, who's talking next, Quadrant's built in Rust as well. Like there are so many benefits to Rust, to building in Rust, from the performance, the speed, but also down to, as a language, it may be slightly harder to get going with as a developer if you haven't used it before. But once you do get past that initial hurdle, the expressiveness and the speed at which you can execute in developing and writing your code is just it's massive. You've also, in Golang, you kind of reach the limits of what was possible with the language, and there was always one way that was good, and you always had to fight the garbage collector. In Rust, that same way that was you were handling it in Golang, there were 15 different routes, and they all have trade-offs, and you've got to decide as an engineer, as a developer, which trade-offs which one you choose, which trade-offs you take on board, and which ones you have to sacrifice. But that decision making is ultimately left with you. You get to choose, and that's really important when you're building something as low level as a database. You have to be able to choose the exact performance characteristics of this asynchronous function, or this channel, or this stream, or this data structure. There are the other benefits that you can Google, the security, the fact that it's built with the kind of the flaws of C and C++ in mind, regarding the developer ecosystem and the memory management. But ultimately, across the board, it's one of the best decisions that we could have made to rewrite the entire thing into Rust. I don't know if Maxwell's got anything to add to that.
Yeah, I mean, somebody may accuse me of being a Rust zealot, but I will be biased because I've written books in the field. But I actually think Rust is the future. I think anyone who competes against a Rust company is going to struggle. And it's not just that I say, oh, I like this language. There's some reasoning behind it. So many of you, I guess, are Python developers. Python is actually quite dangerous. It maps its memory in like a graph-like structure, and it has a garbage collector. So, for instance, a really classic example I do is if you have two dictionaries and then you pass the same integer into those dictionaries, you update one, it won't update the other, right? Because it's done a clone under the hood and it's moved it. Whereas if you do an object instance, you pass that into one dictionary, you pass it into another, under the hood, it will tether those. And then if you update one of them, it will update the other. And you just don't know, right? Because they're the same object pointing to the same memory thing. Now, a lot of Python developers don't unit test their code. So that's why they get all these bugs and they don't know what's going on. the trade-off is that, let's say you say something like C in the past, you could explicitly map where your pointers were. So you could say, I know exactly what's going on, but then you've got the memory unsafety. So garbage collector kind of does some magic behind the hood, and you don't really know what's going on unless you actually properly unit test, because it's really easy to slip up there. But they will silently fail because it's memory safe. Whereas something like C, you get the memory unsafety. So people have made that trade-off and they say, well, I prefer just to have bugs as opposed to complete memory unsafety. And that's why Python and this sort of thing took off. But then Rust just came out of the woodwork and said, I've got memory safety and I can also track exactly where all my structs are and where all my references are. And it will refuse to compile. If you just try and move that same struct object into the two hash maps, you'd have to clone or do a reference. So what I find, is once you start to get used to traits, I actually write less code now in Rust to get a web server up and running than I used to in Python. And then I actually develop at a much quicker rate because I'm not getting these silent bugs that are biting me later on. I very rarely have to go to the production and say, oh, what's going on? My compiler sorted that out before I even shipped it. So what you actually starting to see, and this is why everyone raves about Rust, it's not just this hype, there's a logic behind it, is that the companies that adopt it, they develop much quicker with less bugs, and then they have these compiled binaries that are just much faster than the garbage collected languages. So that's my, somebody may disagree, but I honestly think and it's the same with Zig and stuff like this. These languages are very serious. We had all these different languages that kind of rehashed the garbage collector, and it's kind of just more of a popularity contest. But the ones like Zig and Rust were real innovations, and as a result, like the benefits are so crazy. The Nginx has been written in Rust by Cloudflare. All the major databases now support Rust modules. The White House is now saying you should use Rust. WASM is leaded by Rust. I still use Python for scripting, but that's as far as it goes. It's a bash scripting language for me now.
Very cool. And then, so thank you very much for sharing that. And so maybe one last thing that we could close it out up with, since we have attendees from all levels, and then there's going to be a lot of people watching this once we publish it on YouTube. Maybe you can leave us with a note on what's the best way to transition from Python into Rust, or not necessarily, transition is not the right word, but what's the best way to sort of get started with Rust, especially for ML use cases, if you come from a Python background?
I think I'll leave most of this question to Maxwell, but I think importantly, what we're trying to do with Surreal ML and therefore SurrealDB is not force you to have to move your machine learning pipelines, processes, workflows, anything to Rust. There are projects attempting to do PyTorch in Rust and this and that and the other in Rust, but really it's about enabling you to work in a better way, in a more simplified way with regards to inference and how your models are run, but using the workflow and the pipelines that you use already. So Python, and then using, so we're not forcing you to have to use our platform to build, to process, and Rust. You don't really have to change much. You just change a few lines at the top of your Python file, and you can just push all that to it. But Maxwell.
Yeah, so I am working on the pipelines. So for instance, when you look at something like NumPy, you have a reshape. I've rewritten that in Rust and done the way it maps a three-dimensional vector. And in the unit testing, you test it bit for bit, just like the Python one. You test it against NumPy, and it all seems to fit. So we are kind of rebuilding some of the pipelines into Rust with Python bindings. So you can just use those. You also saw that with polars. So polars is pandas, but written in Rust, and obviously it's just way faster, more secure. You'll be able to do those parallelizable things much more efficiently because of checking of the lifetimes that Rust has. It also has what we call fearless concurrency. So it's very hard to actually get mess ups with the concurrency, right? So you can't just pass a raw pointer over a thread to another one because Rust will refuse to compile and say, you can't guarantee that pointer is still going to point to that same integer or whatever it is. that could get wiped out in the other thread. I'm not doing that, right? So so you get those. I think a lot of packages are already being rewritten in Rust under the hood. If you do want to do Rust, I highly recommend it. Try just doing a few toy programs with a main.rs, with a cargo file, and just hello world, a few things like that, and then learn the Python bindings. So then you can, because I think that's a bit more motivational, because you've already got a lot of code in Python. You just think, oh, is there a little bit that I could use? I could just put that into a Python binding. You have a pyproject.toml. There's already things like maturin and stuff like this, where they'll automatically already handle all the pip install logic. So it will automatically, if you've got a Rust compiler, it will automatically detect the Rust module that you're pointing to and the Python bindings and it will just compile it all and as a wheel and then slot it into your virtual environment. So these things are very easy. They've done a very good job of them. And actually, as I've almost motivated myself, I might actually this weekend write some, tutorials then for Python developers if they want to edge into Rust and still be useful instead of having to build a whole new project 100% in Rust, because we'd be crazy to say that we could completely replace the Python ecosystem. It's a big ecosystem, and there's a lot of really good developers who have developed it, and there's a lot of really good technology on it. So whilst we should look at new stuff and say, yeah, I think this is better designed, we shouldn't poo-poo and throw out all the other stuff straight away, So I think the Python bindings are definitely the best way to go.
Perfect. And actually one last bit, Tobie, and actually for either of you. So in the past, I know that personally, for example, I have come to I have experienced a few issues translating models from one framework using ONNX into another framework, especially if I go, say, for example, something trained in Python, TensorFlow, and then I pass it. Yeah, I convert it with ONNX into like TensorFlow JS. Like, are there any known issues there, or any gotchas, anything that we should watch out for, or have you is the transition between one and the other like pretty smooth at the moment?
Is that me? Are you happy, Tobie?
Yeah, go for it.
Okay, yeah. So transitioning back and forth, we kind of thought that we don't want to overcomplicate things. So we are just directly talking to the direct Onyx runtime. So our flow is very one-dimensional. So it's like you can train in these engines, and we're happy to work with people and add more engines. And then they will get converted into Onyx. Then we've got this Rust Onyx runtime that has Python bindings. So the Python bindings are essentially just a very thin wrapper. And then that means, like, let's say if we do JS bindings, if we work with somebody and we're happy to do JS bindings, then it'd be another very thin wrapper just still talking to that core, and that still does that inference. So it's that sort of way. I think trying to convert it from Onyx to another kind of thing would be quite, I mean, it's doable, right? But it's like, we'll try and keep it as simple as possible, I guess. We want as least amount of errors as possible in that sense. But again, like, if you have anything in mind, and feel free to choose an email or a message. We can look at like inputting it into the CI. If you have a very particular workflow, because we want this to be stable. Like, we want people to feel very comfortable. There's something else I need to add as well, is that because it's the Surreal ML core is separate from SurrealDB, if you want to just edge into it and you say, look, I don't want to buy into the whole ecosystem, but I want to do my own thing, right? Because MLOps do their own thing. There's nothing stopping you from building a Python app that uses SurrealML for inference, or you could build a Rust node that just uses SurrealML for inference. We know that we offer a lot of value in the SQL and the fact you don't have to transfer data from the database to the inference because it's all in the database. So we're very comfortable. Like, that's why we kept these tools very open, very separate, because it's like, look, if you want to do something else, try it out, right? If you have any questions on doing anything like that, just shoot me a message and I can point you in the right direction or help you out. Yeah.
Excellent. All right. Well, thank you very much, Maxwell, Tobie. I think this was a fantastic presentation. It is very incredible to see the things that you guys are doing with Surreal, the ML. and how you're pushing the limits on or flipping the use cases or the way in which we are used to thinking about how databases work, how they should behave, and how we should connect it to one with databases with ML. So this has been a really great talk. Thank you very much to both of you.
Awesome. Thank you.